Welcome to a new video. In this video we will discuss the inverse matrix using the Gauss-Jordan method. We will see how we can proceed from a given matrix to the inverse using the Gauss-Jordan elimination. Of course, we will see that step by step in our calculations for several examples and verify these in MATLAB command window. Okay, we start first with a definition of a Gauss-Jordan method, so how to proceed in general. The procedure is shown here. We have a matrix A that will be augmented with an identity matrix which has the same dimension. And we proceed with this Gauss-Jordan elimination, and at some point we need to create here at the left side an identity matrix. And if that's the case, then you can see at the right side your inverse matrix. So let's see here first a 3 by 3 matrix. So consider in general this matrix A, B, C, D, E, F, G, H, I, so in 9 elements. We add here, so we add to the given matrix an identity matrix, so that will be then augmented. So you get actually the same dimension, but then 3 by 3, so 1, 1, 1, so at the diagonal, the rest of the parameters or the entries are 0. So you augment your matrix with an identity matrix having the same dimension as matrix A. So if you have a 2 by 2, you will have a 2 by 2 identity matrix here. If you have a 5 by 5, you will have a 5 by 5 identity matrix here. Then we apply Gauss-Jordan elimination to reduce the augmented matrix from this form into this form. So the goal is to create here at the left side an identity matrix, exactly identity, and then you can look at the right side and you can find your inverse matrix. Let's see that in action, but we start first with a 2 by 2 matrix to illustrate the concept in an easy way. So again, we use this procedure. So we first augment this given matrix. We already did that using the formula. That's actually a 2 by 2 matrix, so there is no need for Gauss-Jordan method. But we illustrate this also here to see that clearly for this method. So we augment this as shown here, so we augment it with a identity matrix. Now we need to make the row reduction, elimination, in order to get here the identity matrix, and then we look right side and we recognize our inverse matrix. So I start first with multiplying the second row by 2. Why? Because I want to make this 0. So that goes first. So they get now here, this row 1 is the same. This is doubled, 2, 8, 0, 2. You see that here, that's the only change. That means just 2 times the row 2. Next step is I will do the row 2 minus row 1. This is the basic row reduction or elimination in Gaussian elimination method or Gauss-Jordan elimination method. We have also discussed it in the previous videos. Now we will do that, so we go one by one, so element wise, you do 2 minus 2, 8 minus 6, etc. So we see here that the result 2 minus 2 is 0. That's also what we did here in order to do that. 8 minus 6 is 2, 0 minus 1 is minus 1, and 2 minus 0 is 2. Okay, this is still of course not what we want, but we're getting closer because we already have this 0 here, because we want this identity matrix shifted to the left side. So there's already an entry which is 0. So I need to also make this 1, make this 1, make this 0. So now next step is make this 0. That can be done by multiplying the second row here by 3, so we get here a 6. So that's the next step. So first row we just copy, and second row we do that multiplication by 3. So 0, 6, minus 3, and here also 6. And then the next step, I will do that here. That will be then row 1 minus row 2. So then row 1 will be changing and row 2 will be not changing. So you just copy row 2. This is now 2 minus 0 here. 6 minus 6 will be 0. 1 minus minus 3 will be 4. And 0 minus 6 will be minus 6. So now you see already that we have another 0, which is then we're getting closer to the identity matrix. I now need to make this 1 and this also 1. So that can be done pretty easily by dividing this by 2 and this is by 6. And this is what we now do here. So row 1 by 2 and row 2 by 6. Now you get here the following result. This is then 1, 0. This will be then, because you divide by 2, will be a 2. This will be a minus 3, you divide this by 6, so there will be 0 still. This is a 1, this is a minus 0.5, and this is 1. Now you see here this identity matrix as we wanted, and here if you look to the right side after this vertical line, that will be your inverse. And this inverse we also had from the formula we have seen before. So we can say that our inverse matrix is indeed as we have calculated, and that's also determined from this Gauss-Jordan method. Okay, now let's also look at in the MATLAB. So if this is really correct. Now this is the MATLAB command to create this matrix 2614. We use this inf and a parentheses a to calculate the inverse of this matrix, and now we have here the result. You see here the 2, minus 3, minus 0.5, and 1. So this is indeed as calculated. Now let's see that also for a 3 by 3 matrix, because that is more interesting. Now we have here now 3 by 3 matrix, or 9 elements. How do we work it out? Again, we augment this matrix. Now in this case we need to use an identity matrix which is 3 by 3. And we proceed again in order to make this 0, this 0, this 0, that's really the order, and then this 0, and that 0. And then we need to do the final step in order to make this all ones. So we do more steps here because we have a 3 by 3 matrix. We start first with making this 2 times and making this also 2 times, so we have all 2's here. So what we have is double the first row and double the third row. So the second row is just a copy. You just take it over, double this, we get here 1 times 2, so 2, 4, 6, 2, 0, 0. You double this, so it will be then 2, 0, 16, 0, 0, 2. That's all shown here, so everything must be doubled. So we need to check this carefully. Then we can do row 3 minus row 1 and row 2 minus row 1. Why? Then we have this 0, that is 0. So these are the 2 operations I do one by one. That means row 1 will stay the same. So I take that first, copy that, and I will do this first. So 2 minus 2 is 0, 5 minus 4 is 1, that's shown here, 3 minus 6, that's minus 3, 0 minus 2, that was minus 2, 1 minus 0, 1, 0 minus 0 is 0. Next one, 2 minus 2 is 0, 0 minus 4 will be minus 4, 16 minus 6 will be 10, 0 minus 2 will be minus 2, and 0 minus 0 is 0, and the final one is 2 minus 2 is 2. Now, next step is I need to also get rid of this one, so I can say let's make the row 2 4 times. That's what we can do, but we can also say in a different way. You can say let's divide this first row by 2. That is a different way to do that, and also you can also divide now the third row by 2. Let's do that first. So there are different ways to go, but I will also show you that. So what we have is then everything is then here divided by 2, and here also divided by 2, and this is unchanged. Now what do we do next? Now we can now look at this, and this is the procedure I want to make. Now we can say I want to also double this second row. Why do I do that? If I do that, I can also get here a 2, so that is then everything is now in 2 2's here, and I can now make this operation easily. So only the second row is changing. Now the first and the third row can be just copied. So double this, double that, so every entry here in the second row, and you get these values. Next one, now we need to make this 0. That can be done by using the R3 plus R2, because then we have a 0 here, because this is 0 plus 0, minus 2 plus 0, and etc. Then you get the results here. You see that here, minus 1 plus minus 4, 0 plus 2, 1 plus 0. So you see here the results. Now we're getting already closer because this is 0, 0, 0. Now we need to make these 0, and then final one, we need to make this all ones in the diagonal. Okay, next steps. Oh, what do we do next? Now I need to make this 0, so let's make this 6. That means let's double this, because I need to make the 3 into a 6. That means, and I also need to make this something which is later also with a 6. So let's also make this 6 times. Okay, now we have this. You see here now the row 1 has changed because we doubled everything, and row 3 has changed. We also multiply by 6. So you see that all the entries here are times 6. The next step is then row 1 plus row 3. Why not row 2, you might say? It is easier to do that with the row 3 because we get here more zeros. It doesn't matter, you can also use this, but it is handier to use a row which has more zeros. Okay, now we will do that. So that means the following. And we can also do row 2 minus row 3. That is another step, so we get also a 0 here. So we do 2 steps at once here. That means row 3 will be the same, so it doesn't change. This will be then, by this operation, change this one. So you can also see that by looking at this one. So 2 plus minus 30 is minus 28. 0 plus 12 is 12. 0 plus 6 is 6. So in the other case, you also do the similar case, but then use row 2 minus row 3. Okay. What do we do next? Now we have already here 0, 0. We're getting closer and closer to the situation we want here, which is an identity matrix 3 by 3. I want also get rid of this one. So I can say, let's divide this by 2, or let's double this in order to get the same value here. So I divided now this by 2, so I want to get smaller values. So I have here 1, 2, 0, minus 14, 6, and 3. The rest is the exact same. Now the next step is, as mentioned here, we need to now do the row 1 minus row 2, because I want to have a 0 here. That's now happening here. You see that? And that is not changing. That is not changing. So row 2 and row 3 are just exact same. So we just copy them. Only change is the row 3, or I mean row 1. What happens next? Now we are now very close. We only need to make this one. It's already the one, but we need to make this one, and we also need to make that one. So that means we need to divide the second row by 2 and the third row by minus 6. That's shown here. So we just copy again the first row. That's good. Second row we need to divide by 2, so it will be then 13 minus 5 minus 3. We divide this by minus 6, so it will be then 1, 5, minus 2, and minus 1. Now you can see here the identity matrix in the 3 by 3 dimensions. So, and we have here the right side, its inverse. So we have here the A inverse is the matrix. Here we see here the entries. You can check this by multiplying this matrix with that matrix, and that should result in the identity matrix. That is the check you can do. Okay, now let's check that also in MATLAB. Now this is again the MATLAB command we did also for a 2 by 2 matrix, but in a similar case. Now for a 3 by 3, you see here 1, 2, 3, first row, second row, 2, 5, 3, and 1, 0, 8. This is also shown here. Now we also calculate the inverse of that matrix by this command. And this is the result. You see here minus 40, 16, 9. That's the first row. 13 minus 5 minus 3. 5 minus 2 minus 1. And that means next to each other. You can see that clearly. That is indeed correct. Alright, that was our example concerning the Gauss-Jordan method for computing the inverse. If you have any questions, comments, please let me know. I will try to answer them as soon as possible. See you next time in another video.